So building on the 2-position coupler output, what we're going to look at is 3-position coupler output. Okay, 3-position coupler output follows a very similar approach. In 3-position coupler output, we're going to look at these 3 positions. So here is position 1, here is position 2, and here is position 3. We're going to do a similar approach. We're going to draw the displacement vectors from A to A prime, and then from A prime to A double prime. Do the same thing here, B to B prime, and then B prime to B double prime. Okay, so what we have here is draw displacement vector A to A prime and A prime to A double prime, and then B to B prime and B prime to B double prime. Now there's 4 lines here, and some common mistakes are going to be that you'll go from A to A prime and then from A to A double prime, and you'll go from B to B prime and from B to B double prime. This is not the case, right? If you think about what's going on, A has got to move from this position to this position, and then that has got to move from A prime to A double prime. So these green lines represent the displacement vectors. Okay. Now, the next step is to draw the perpendicular bisectors Okay, we're going to draw the perpendicular bisector of A to A prime, A prime to A double prime, B to B prime, and B prime to B double prime. So there's going to be 4 perpendicular bisectors, and we'll make those purple again. So our perpendicular bisector is going to come down here, okay, and we'll label that perpendicular A to A prime. It's going to come down here, perpendicular bisector B to B prime. It's going to come this way, perpendicular bisector of A prime to A double prime, and then we'll come this way. We'll try that one more time. We'll come down that way. So this is perpendicular bisector of B prime to B double prime. Okay. Now the third step is where the perpendicular A to A prime and perpendicular bisector of A prime to A double prime intersect is O2, and the fourth, where the perpendicular bisector of B to B prime and perpendicular bisector of B prime B double prime intersect, is O4. So this is important. So I've got perpendicular bisector of A prime, perpendicular bisector of A prime A double prime, and here I've got a ground joint, right? And I'll do the same thing for the B, perpendicular bisector of B B prime B double prime. That's O4, and this is O2. Step 5 is to connect O2 to A, and step 6 is to connect O4 to B. So I'll draw my links in orange, and what we have is here and here. So I can okay. So now what I have, I've got L2, L3, L4, and L1. So I've got L1, L2, L3, and L4, right? This is the coupler. This connects O2 to A. This connects A to B, this connects B to O4, and this connects O2 to O4. Okay? I can go back and check Grashof. I could do a motion analysis. Okay? But what I've done here is I have realized or synthesized a linkage, in this case, to drive this coupler through these three positions. In the next set of videos, we'll add some more complexities to this and go through and talk about some of the unique ways we can do some synthesis with these basic